All right, so we are ready to begin our first unit in physics, and the title of that unit is called kinematics. And what you're going to find, the first two units that we do, both deal with motion, and these two terms that we have here listed first describe Unit 1 and Unit 2. So kinematics is a study of motion, observing how things move. And then when we work into Unit 2 on forces, we call this dynamics, and it's a study that of why things move or how motion is produced in the first place. So we say that kinematics is observing, dynamics is explaining, so providing an explanation as to why things move. When we start working with numbers and formulas, we're going to be working with two different types of quantities, basically. And those names of the quantities are scalars and vectors. And it's very, very, very simple, the difference between the two. Both involve numbers, both involve units. The only difference here is that a vector has direction. And so any numbers where there's a direction stated after, we call it a vector. Any number where it's just a quantity or amount of something, it can still have units, but it's scalar if it does not have a direction associated with it. It doesn't always have to be west, east, north, or south. It could be left, right, up, down. Any type of indication of direction makes a quantity a vector. Okay? So if our first unit is kinematics and we want to be able to describe how things move, there's some terms that we have to learn first in order to do that. And you're going to notice that there's very similar terms that we're going to learn here, but I've placed them under the two different columns of scalars versus vectors. In everyday language, we might say speed is the same as velocity, but when we learn about scientifically what speed is versus velocity, there's a difference to them. So remember, on the left-hand side here are scalar quantities. These are things that do not have to state a direction after. So the first term we're learning is distance. It's the total length of the path traveled. We use a lowercase d to represent this. Anytime we use a letter to represent something in a formula, we call that a variable. So you'll hear me use that term often. And then when we measure our distance, we also have, in physics, we have what's called standard units. And I'm going to tell you, and I'm going to state as we learn new terms, variables, and units, I'm going to state what those standard units are. So anytime we measure something in distance, we're measuring in meters. Okay, and then speed. Speed is the distance, so the total length of the path traveled divided by time. So how long did it take you to travel that distance? And we use a lowercase v. And because we're taking distance, which was in meters, divided by time, which is in seconds, this is our standard unit of time, we end up with a unit of meters per second. Okay, now I'm just going to jump over here to the right-hand side. Remember, what's on the right are vector quantities. Means only real difference here is that we have a direction associated with it. And when we're talking about distance versus displacement, displacement is a change in position, okay, from start to finish. So let me just add that in there, actually, because that's important. A change in position is, okay, so this is from start to finish using a straight line. And you're going to see what I mean by this in a minute. I'm going to make this bigger just so you see this. Okay, so when we talk about the change in position, we can have multiple movements. And when we talk about displacement, all we really care about is where did you start in relation to where you finished using a straight line. Okay, whereas distance is the total length of the path traveled. So let me just give you an example that you might be able to relate to. If you live in the Niagara region and you had to get in your car and drive to Toronto, you're going to drive over 100 kilometers around Lake Ontario to get to Toronto. If we were to think of our distance, the 120 kilometers, let's say it is, would be our distance. It's total length that we had to travel in order to get from point A to point B, or start to finish. If we look just overhead view of a map and we think about, we started, let's say, in St. Catharines, Niagara region, and we just used a ruler straight across Lake Ontario to get to Toronto, that is our displacement. Okay, even though we didn't take that path to travel there, displacement is only concerned with where you started to where you finished. And because it's a vector quantity, you're going to notice that we put these little arrows on top of our variables. So it's still a lowercase d like distance, but we put a little arrow on top to represent that it's a vector quantity, and that little arrow tells you that you should have a direction in your final answer whenever you're stating anything about displacement. Now, when we get to velocity, it's very, very similar to speed. It's our displacement divided by time, just like it was distance divided by time. The only thing that changes here is instead of using the total length of the path traveled, we're using where did we end up in relation to where we started, and we're dividing it by the time in seconds. Still in meters and still in seconds. So you're going to see these two formulas are almost identical. But these tiny little arrows on top of our variables tell us that we're dealing with a vector quantity and that this lowercase d is displacement and not distance. So that's what you want to keep your eyes peeled for. Okay, so time, I told you the standard units are seconds. It's a lowercase t to represent time. And here's a symbol that you're going to see sometimes. It's called the delta symbol. And it's basically just a triangle that is put in front of a variable. And all that means is it's the change in something. So for instance, if we wanted to know our total displacement or our change in displacement, we would be taking our final displacement minus our initial displacement. The 2 to represent your finishing position, 1 to represent your initial position. Some textbooks, and I think ours does this, instead of using a 2 and a 1, they might use an F and an I, so for final minus initial. So when we're talking about displacement, time, or velocity, if you see this delta symbol in front, it means the change in. What was your finishing value subtract your initial value? Okay, let's have a look at an example together. So a jogger runs around a square city block that has a side length of 500 meters. So if it makes sense to make a diagram and add to the diagram, then do that. So we know that every side, is 500 meters. Because sometimes it helps you to visualize things. Okay, 500 meters and 500 meters. As you read through your word problems, another great strategy is to highlight any of the given information. Okay, so they gave us 500 meters city block. What is the distance? So in another color, I'd say what is required of us? What is the distance and what is the displacement? If this jogger runs it twice. So here's another piece of given information. This jogger ran around the city block twice. So here's how you're going to approach a situation like this. Figure out a start. Doesn't really matter because it's going to make a complete block. It starts here and it goes around twice. So 2 times. So if we look at distance, lowercase d, 500 times the 4 sides is once around the city block, and it's going twice, so we're multiplying it by 2. Remember, definition of distance is total length of the path traveled. So what we end up with is a total of 4,000 meters for distance, and we're done. Don't forget to include your units. Okay. Displacement, on the other hand, is still a lowercase d, but it's a vector quantity, so we put the arrow over on top. And if by definition our displacement is where did we finish in relation to where we started? Well, if we're going around a city block twice and making 2 complete loops, we are actually, I use this S to represent my start and F for finish, we're finishing in the exact same spot as we started. So our displacement in this case is actually 0 meters. And yes, we would put usually a direction if there was an actual quantity to deal with, but because we end up with 0 meters, we're not east, west, north, south of the point we started. We're actually on the point we started. But because it's a vector quantity, get in the habit of stating distance at the end when you're asked. Okay, and how does this relate to B? If it takes him 12 minutes, determine his average velocity and speed. So here's given information again. And here is required information. Okay, so we want to find v, which is our speed, and we want to find velocity, which is v with an arrow on top. Okay, by definition, so let's just speed. This is velocity. By definition, speed is equal to distance over time, but velocity is equal to displacement over time. And we have both of those pieces of information. What we don't have, well, we have our time, but remember, time has to be stated in our standard units. So this is where I want you to get used to. When I tell you what the unit should be for one of the problems, you want to keep that same unit throughout. So we don't want meters per minute. We want both units to be in our standard format. So 12 minutes, there's 60 seconds in a minute. So we end up with a total of 720 seconds. So now it's just a matter of straight substitution. So we had a distance of 4,000 meters over 720 seconds gives us an average speed of 2.8 meters per second. And our velocity is our displacement divided by time. Well, our displacement was 0 meters. And our time is still 720. So we end up with a displacement of 0 meters per second. Okay, final example. Sarah throws a ball 3 meters east relative to herself. Her dog retrieves it and stops 15 meters west of Sarah. So, determine the distance and the displacement of the ball. Okay, so here's a situation where we have multiple movements, and this is their given information. I should use the same color for my given information. So given, and so what we're doing is we're tracking the path of the ball. So Sarah throws a ball 3 meters east relative to herself, then her dog grabs it, brings it back 15 meters west of Sarah. So what the best thing to do with these is to try and, again, visualize what's happening here. What we're trying to find is the distance the ball traveled and the displacement that the ball traveled. So first thing you want to do, Sarah throws a ball 3 meters east relative to herself. So we need to kind of just pick a spot on our paper that's going to represent where Sarah is. So this is Sarah, and it also represents our start, and I'll just put that in a difference. So S for start. Our ball goes 3 meters in this direction, which is east. And then it says her dog picks it up and then runs with it and ends up stopping 15 meters west of Sarah. So what that means, that grabs the ball here, goes all the way back to Sarah, plus another 15 meters. So from here to where the ball ends up, so here's the ball's finish, we are 15 meters west of Sarah is this distance here. And from here, the start to where she throws the ball is 3 meters. So all we now have to do is remember what our definition of distance and displacement are. Distance is the total length of the ball that the ball traveled. So if it started here, it went 3 meters in this direction, and then it came 3 meters back, plus another 15 meters past Sarah. So total length of the path traveled is our distance. 3 plus 3 plus 15 is 21 meters. And our displacement, remember displacement is a vector quantity. We put the arrow on top, and all we're concerned about now is where did the ball start, where did the ball finish? And when we're dealing, so the first part of this unit, we're just dealing with things moving in one dimension. So even though I've separated these two lines, we can assume that it's moving left and right or east and west in this same plane. So it's just moving left and right, and we're not considering whether it goes sideways at all for any of these questions when we're talking about one-dimensional motion. Okay, so our displacement, we just want to know where did it start and where did it finish, and what distance separates those two if we were to use a straight line. So if you see the difference between start and finish is 15 meters in the west direction, then our final displacement is 15 meters and it's west. So remember, anytime you have a vector quantity, you have an arrow on top of the variable and you've got a direction over past your final units. And that's it.